Once upon a time and to this day we still live the mathematical story of complex numbers. So let's figure it out.
Hey ibtissam, what's wrong with you? What's bothering you, dear? I'm tired of this lesson of complex numbers. Why we study imaginary numbers? They are without meaning. Well, just calm down. I'll help you answer all your questions. But before that, hold this bottle from me. Oh my god, she'll start to lecture me again. Ta-da! So before we talk about these imaginary numbers, we must first know what do we mean by the term numbers? And what's difficult about that? Numbers are mathematical elements used to count objects and quantities in the real world. In fact, numbers are different from what you think, as this idea about numbers is stereotypical and very old. Furthermore, it has led to a delay in mathematics for hundreds of years. So simply, numbers are therefore used to express realistic and logical concepts. Otherwise, what's the meaning of negative number then? Is it reasonable to say that I have minus 50 dirhams? First of all, imaginary numbers are born from confrontation with impossible operations like the square roots of negative numbers. If our math teacher hears you, you will be in a big dilemma. Indeed, the conceptualization of imaginary numbers dates back to the 16th century with the Italian mathematician Girolamo Cardano, who proved that having a negative term inside a square root can lead to the solution of equations of degree 3. So, Cardano was the first to imagine the existence of these numbers on his Artis Maniae Severigulus Algebraicus on the equation of the resolution of the following equation. Then, it's Raphael Bombelli who sets up the rules of calculation on these quantities in his algebra, which then call impossible before giving them the name imaginary by Descartes. Secondly, it should be noted that any real number is represented by vectors on the real number axis. But how do we represent this number? Here the problem was. So we need a number that we multiply in itself, so he does half a cycle to give us minus 1. So, according to the imaginary numbers, the solution is the square root of minus 1. Since this notation is not accepted in mathematics, Euler called this number the number I. And he added an axis perpendicular to the real axis, which he called the imaginary axis. Later in the 18th century, Gauss refused to call them imaginary numbers because imagination with math is weird. So he gave them the name complex numbers, which are written in the form z equals a plus ib. And this is what you study now. Of course, complex numbers are so important as they allow us to find solution of many equations that have negative discriminant delta. In addition, they also use in quantum physics, technology and analysis of electrical circuits.
A few moments later.
Interested. I get you now. Oh dude, you should participate in the competition of the best mathematical video in Morocco. Yeah, that sounds great.